Okay, so here we're going to look at a work question with variable force, and it's going to be in the context of a spring. So, first thing with springs is remember Hooke's law. The force required to stretch a spring is the spring constant times the distance. So, when you're looking at this integral for work, f of x is k times d, or just k times x. So the question says we know there's 6 joules of work that are required to stretch it 0.5 meters. So 6 joules is work. So we're going to go 6 equals the integral of f of x dx. So that would be Hooke's law, k times x. We'll use x for distance. And it says 0.5 meters from its natural length. So we start at its natural length, which would be 0. It's not compressed or stretched at all, and we're going to 0.5. So we can use this equation to solve for k. When you integrate kx, you get 1/2 k x squared. I'm going to just multiply that 2. And then we'll have, when you plug 0.5 in, you get 1/2 squared, which is 1/4. And then plug 0 in. So you have 1/4 k equals 12. So k equals 48. And that would be joules per meter. So the question is now, find the work required to stretch it an additional 0.25 meters. So now that we have the spring constant, we can now say the work here for this particular spring is the integral of 48x. Now, if we want to stretch it an additional 0.25 meters, that means we're starting at 0.5 meters. That's how much it's been stretched so far. And we're going to do 0.25 meters more, so we'll stretch it to 0.75. So this would be 24 x squared integrated from 0.5 to 0.75, or just 24 times 0.75 squared is 9 sixteenths, 3/4, right? Yes. Minus 1/2 squared is 1/4. So this would be 24 times, so this is 8 over 4. I mean, 4 over 16, so 5 over 16. And then, let's see, 8 goes into both of those, so this would be 3, 2. So we have 15 halves, and that's joules. So that's that.